Hello everybody, welcome to the 19th tutorial, and in this tutorial we're going to be looking at game objects, and basically it's going to be based on inheritance and polymorphism in Java. So basically, anyways, we're almost done writing basic engine code. All we have left is basically creating a hierarchy system for adding objects to our game, rendering a scene, and also creating animations. So I went ahead, since I'm a horrible teacher at explaining stuff, I went ahead and looked up what is inheritance inside this website, tutorialspoint.com, and yeah, so I'm just going to try and read this definition. So inheritance can be defined as the process where one class acquires the properties, methods, and fields of another. With the use of inheritance, the information is made manageable in a hierarchical order. The class which inherits the properties of the other is known as a subclass, which is a derived class or a child class, and the class whose properties are inherited is known as a superclass or a base class or a parent class. So that's basically inheritance, and yes. And what else we have is polymorphism, and this is something else. So polymorphism is the ability of an object to take on many forms. The most common use of the polymorphism in object-oriented programming occurs when a parent class reference is used to refer to a child class object. Any Java object that can pass more than one is a test is considered to be polymorphic. In Java, all Java objects are polymorphic since any object will pass there is a test for their own type and for the class object. It is important to know that the only possible way to access an object through a reference variable So you're gonna read through this stuff and yes. So anyway, so I'm just gonna try and illustrate this stuff for you. So I'm just gonna try and open Paint. And there we go. So what we're going to be doing today is we're going to be creating a hierarchy system for our game and adding game and yeah. So as you can currently see now, when you go to our game manager class, our game manager has the code for a map, which is basically the buffered map image and all this other stuff, has information about the map, and also has information about the player, which has the buffered image, its position, its transform, and all this stuff. Now, this isn't good programming. This isn't actually good. Oh, I forgot to change this. So this isn't actually good programming. I forgot to change this. So yeah. So this isn't actually good programming when you have code about something else inside a different class. Like the game manager should only have code that manages your game. It should just be managing the game, managing who gets updated when and at what time, who gets rendered at what time and when, and all that other nice stuff. But we have player code inside the update function. This shouldn't be inside here. This should be in a player class. And we have this buffered image map inside the map rendering function, inside rendering code inside the render function, which it also shouldn't be here. And so yes, so the other problem comes is if you want to create new objects, we'll have to clone every single property we have and create the object again from scratch. So anyways, I don't think I'm making sense. Let's just get onto the paint board and let me try and explain this. So so the hierarchy that we're going to try to create is we're going to have our game object as a superclass. It's going to be the base class or the parent class, and from the game object we can have other stuff. We can have an entity, which you can't type in text. Oh, you can. So you can have our game object, and in here we can have, and here we can have an entity, and after the game object we can have something else. We can have, I don't know, we can have other objects, like we can have an obstacle. It's an object. and here we can have a I don't know, yeah, we're just gonna name it entity, and inside the entity we can have two other things. We can have a player and have a player, and with the entity element we can have a zombie, and what else can we, and with zombies you can have different types of zombies. Oh, I ran out of space. That's odd. So we can have, like, I don't know, like a green zombie, I don't know, that's a speedy zombie that's very fast, and we can have a, I don't know, I'm just gonna call it a bouncer zombie that's going to be very tough and gonna have lots of damage. Okay, that isn't working out, so let me try here. Bouncer. We can have a bouncer, and there we go. So basically, as you can see, we have a hierarchy. So every single, with the system we currently have in place, if we need to create a player, if we have a player, we're going to have to create another position object, another transform object, and all this other stuff. But actually, in essence, what we should do is we just create one class, and as the game object, it's going to have a position object. It's going to have a position attribute or field or whatever property. It's also going to have a transform property. It should also have a, I don't know, what else do game objects have? A size, a width, and a height. And when we create these other stuff, like we can create an obstacle, an entity from the game object, it's already going to inherit these stuff. It's going to inherit position, transform, and size. So with inheritance, since we already have the game object having a position, a transform, and a size, when we go ahead and create an entity, what all the entity is going to have is basically a health, a direction, and a speed. And a speed variable. And look at this, we don't need to create a size for the entity because entity extends from game object, so it already inherits all the properties from the game object. So it's going to have a position, a transform, and a size, but all we have to do in the entity class is basically declare a health and a direction and a speed variable. Now when we go to the player, we're going to have other stuff, like it's going to have weapons and guns. Weapons, we're going to have grenades and stuff, grenades, and a bunch of other stuff. And when we get to zombie, they're going to have AI, artificial intelligence, and what else? And they're going to want to eat your brains. And there we go. And deep down, when we go to the speedy, it's just going to have fast. It's going to be fast, and for the bouncer, it's just going to be strong. And there we go. So basically, even though when we create a speedy zombie, what the zombie is going to have, the only attribute inside the class will be probably fast and its damage and its health and all this other stuff. But since it's going to inherit all these other stuff, we don't need to create a health variable inside the speed. You can simply just set it, access it inside the class, but we don't need to create it again because there's a hierarchy. Yeah, so because every single class inherits from the previous class and inherits from the previous class. So this is what inheritance is. So anyway, so we're gonna create something like this in Java, and I think I spent 9 minutes explaining this, and so let's get on to coding. So what I'm going to do is I'll go and create a new package, and I'll call it game object. Create a new Java package. game object, and inside there we're going to create a new Java class, and I'll name it game object, and it will simply have a vector position, a vector 2f position, and then a fin transform, whatever, transform, and there we go. We might also want to I don't know, we might also, yeah, I don't know. So anyway, so let's go and create a, it also have a size, a width, and a height. So we're gonna create a float, width, height, float with height, and let's go ahead and create a constructor, a default constructor for this, and we just simply say position equals to new vector 2f, affine transform equals to new affine transform, new affine transform, and default width and height, I'm just going to set it equals to 50, equals to height, which is going to equals to 50f, and we need to make this public. And yes, so we're just gonna copy, Control C and Control V, and now we're just gonna change this. So the next constructor, oh my goodness, so the next constructor we're going to have is vector 2f. So it's just gonna take in a vector, and a size, and a width, and a height. Can't spell height. Make sure these are floats. Position, basically setting stuff. So we're just gonna set stuff, and so basically creating a constructor, and we're just gonna say this dot width. No, wait, it's the other way around. This dot width and this dot height and this dot position, and basically this is it. So the other thing we need to do with inheritance, we create values and as protected. Reason being, we just want to refer to them from the children class, and yes. So the only way we can refer to the position value is by having either having a function that returns the position, or basically inside the child class. So the other thing I want to do is to insert code. I'm not going to type this, it's just going to take a long time. So it's alternate plus insert. Alternate, okay, what's alternate I? We're going to just generate getters. And generate, and there we go. We're done with that. Now the other thing that we're going to have is we're going to make this class abstract. Now this is probably going to confuse us a little bit, but yeah, T, abstract with a T. There we go. And I'll explain that in a moment, and we're going to create some abstract functions. Public abstract void update. Public abstract void render graphics 2D graphics. Now basically, let me just explain what abstract means. So basically what abstract means is basically, as you can see, it's a method or a function without a body, meaning that it's not going to have any code inside of it, so meaning that the game object by itself will be useless. This class is meant to be a parent class and shouldn't be created by itself. So what does this abstract void update and abstract void render mean? As you can see, if we call these methods, nothing's going to happen. The reason being is these methods, when we inherit anything, when any class inherits from the game object class, basically what's going to happen is it will have to have an update method, and it will also have to have, it's mandatory for the children classes to have these two functions, these two methods. So yes, I'll show you that in a moment. And what does this abstract mean inside the class? So if you have an abstract function or a method, you must have the word abstract before the class to declare that it's an abstract class. So inside the game object, I'll just go ahead and create a new Java package, and I'll name this entities. And inside there, I'll just create a new Java class, and I'll call this entity. And I'll just show you. So basically, when we inherit from a class, we basically use the keyword extends and the name of the class, game object. And we will need to import this. Import the class. And yes, now as you can see, the other error is entity is not abstract and does not override abstract methods render in game. Those two abstract methods implement the unimplement, whatever that says. Now what we're just going to do is simply implement all abstract methods and all this stuff, and we're good to go. So as you can see, every single class, what I was explaining is that every single class that extends the game object is going to have these two functions for it to work. There we go. But I'm going to remove them because an entity is also going to be another abstract class, because we're going to have a player and a zombie inheriting from this. I'll just say player. What? Abstract. And what else can we have inside an entity? Now an entity can have it can have the health. It can have health. So we're going to create a protected float. Protected float health. And what else can an entity have? It can have a speed variable, float speed, protected float speed. What else can, okay, so I think directions is already specified. No, okay. It can have a direction, vector 2f, protected float, not float, vector 2f. Sorry about that, I had to make sure something was done. I had to take care of something, and yeah. So, projected vector 2f. So what is it? Oh yes, direction. So that was still the direction. What else should an entity have? So it should have health, speed, direction. Should be able to rotate. No, but every single game object should also be able to rotate. So I'm going to create a new float here, and I'll simply name it rotation. Rotation angle. protected, and there we go. So we have health, speed, direction. Let me look at my thing. So health, speed, direction. So that's all the basic stuff we have. We're not gonna create a zombie class for now, and we'll simply just create a player class inside entity, because a player is an entity. New Java class. Player should be player, not an impaler. So there we go. Player. Create a player, and we're simply going to say extends entity. So the other thing that we didn't do is create a constructor for the entity. It's going to be public entity, and we're gonna have two constructors. A default entity can have a health of, I don't know, health of 100. Health equals to 100. Speed equals to 100. Direction is going to have a direction of nothing, 0, new vector 2f. No, in fact, default entity should have 0 speed, 1 speed, 0 speed, I don't know, 1, yes, 1 speed. Direction equals to new vector, now let me just go with 1.2, 1.5, I don't know. Default entity has a speed of 1.2f. Direction equals to new vector, and there we go. And we're gonna create, no, also I need to call super. Now, yes, so I actually got a chance to explain to you what super means. So basically, when you just call super and you have these two brackets, we're calling the constructor, the constructor of our super class. So if I control click on super, it's going to take me to this constructor here. So whatever happens when I call super, we're just going to call this constructor first. So we're just going to initialize the default game object and initialize the default entity. And now let me show you another instance of how we use super. Public entity. And this time we're going to take the position. No. Let me just copy and paste this. Control C, Control V, and we're going to have a vector 2f, which is simply going to take the position. Vector 2f position, and what else? We're going to have float width and float height. And now we're going to be calling this other constructor. The second constructor is going to be position width and height. And when we do this, I'll just simply copy all the stuff in here and paste. And yeah, so I just have to remove this stuff. And there we go. Now, if you control click on this super, it's going to take us to this constructor. So basically, super calls the constructor. When you say this super as a function, it's just simply going to call the constructor. And there we go. We just need to generate getters for the stuff. Probably wondering why we're just generating getters, not such as this. It's just for encapsulation purposes, and that's about it. Let me remove this import. Not used. We don't need it. Getters. So I'm just gonna right click and go to insert code and getters, your entity, and generate. And there we go. So we're done with all the stuff. Now we're just gonna go into our player class. We're gonna go into a player and we're gonna simply say extends entity. We're going to implement all abstract methods, and there we go. and we're going to have the player constructor, public player, so we're just going to simply take a vector position, vector 2f position, and inside here we're simply going to call super again, and now we're going to pass in the position and a default width and height of, I don't know, 150 by 150 pixels. And mouse, cannot reference position before super type. Okay, there we go. Position, and there we go. So that's it, and this is our player for now. And yes, so guys, if you like the video, please hit the subscribe button and like. And yeah, sorry for the long video. And anyways, so in the next video, we're just simply going to be refactoring our player and move all the stuff from the game manager. Move all the stuff from a game manager, and we're gonna put that into the player. Moving all this code, simply refactoring all this code, moving it to the player, and we're gonna make sure that it works fine. And so yeah, that's about it, guys. Peace.